Okay, so this is our last day of review for this algebraic manipulation test, number 4. Basically, it's all about logs, and log properties are used when you solve the equations. Algebraic manipulation means that you have to be able to be really good at solving things, getting the x alone. So we got all kinds of tricky things that could happen. All right, this first one is very simple. Is the x alone yet? No, so you just have to rewrite it. Rewriting is the fundamental thing that you have to know about logs. You got to be able to go from exponential form to log form and back and forth. So this one would become 5 to the 12th equals x, and that's it. Isn't it solved for x? Yes. Now if there's something simple you can do, you should do it, but do you know what 5 to the 12th is in your head? No, it's a massive thing, so you leave it that way. So this test has a lot of that. Since there's no calculator allowed, you simplify where you can, but a lot of times you have to leave your answer with some complication. All right, let's do another rewrite. This time the x will be in a different spot. Notice that the x was in the argument. Remember that that's called the argument? What's that spot called again? The base, and that thing's called the exponent. See how it turns out to be the exponent on this? So this is the argument, this is the base, and this is called the exponent. All right, so let's put it where x is in the exponent. Log base 3 of e equals x. If I put that on the test, a lot of you would just strain your brain trying to figure out what the answer is, and what's the answer? Log base 3 of e. Because if the point is to solve for x, isn't it already solved? Hey, that's the answer. All right, another trick they could do to you. What if they made that -5? No solution, because you can't have negatives there. All right, what if they said it was 0 here? Is that okay? You can have a 0 there? All right, so let's just double check it to make sure that's all right. 3 to the x is equal to 0. Is that possible? No, you can't. Some of you are thinking 1, I think. But anything to the 0 power is 1, but anything to the 1 power is itself. So 1 doesn't work. There is no answer that would work. You cannot have a 0 there either. Can you have a 0 here? No. Bottom line is they have to be positive numbers. You can't have zeros, you can't have negatives in these spots. This, anything goes. The exponent can be negative, it can be a fraction, it can be decimal, it can be anything. But these two spots, log base a of b equals c, a and b both have to be positive. They can't be 0, they can't be negative. All right, how about this? Here's another property. What's c equal to? Zero. It's a property that whenever there's a 1 right here, then the answer must be 0. Now think about it for a second. If I just ask you to rewrite that. Something to the something that needs a pencil. You'll need to do that on paper. Go ahead and rewrite that. A to the c equals 1. Now think it through. What does that have to be? 0. Now it is possible that if a was what? 1. If a was 1, then c could be 1. But, okay, so that wasn't a great example, but I should have had a number there, like 12. Then I could say automatically c is equal to what? 0. Because 12 to the c equals 1. The only number that would work there is a 0. So this is a property that if this is a 1, then that's got to be a 0. All right, moving on. This one, you can mush the left side together. It's called compressing. When you do that, it'll make the problem way easier to solve. Do you get how this is one of those pluses and can be therefore changed into a single log? Compress it down to just one log. Log base 4 of what now? Is it 3x divided by 5? 3x times 5? 3x times 5. And then that is really what? 15x equals 2. And again, whenever you're stuck on one, trying to get x alone, and it's not like looking easy to get alone, rewrite it. Mr. S, tell me what to rewrite it as. It already is log base 4. Try that the other way. 4. There you go. Yes. And now, is that close to being alone? Yeah, I just got to one last little thing, which is what? Divide by 15, divide by 15, and then this cancels, and x equals that. And could you simplify some of that? Yeah, because 4 squared is really what? So 16/15 is the answer. All right, another kind. What's going to be handy with these two blue lines? Take a wild guess what the two blue lines are for. Yes? It kind of has to do with the log base 4s. Yes? Yes, so that's what they're for, see? Boink. So now what's the answer? Yeah, because 4x equals 20 and x equals 5. Why could I cancel those? Because they were the same base. And if you just think about it for a second, I'll give you a simple one. Log of x equals log of 5. That's the same base, right? They're both base 10s. Then the only way that works, if this is really going to be true, is if x was 5, right? So that's why you can cancel those. Okay. All right. This one. This is one where you want the bases to be the same. All right. That needs to go on my desk. That 25 could be written as what? 5 squared. Once I've got it rewritten as 5 squared, now everybody try to finish this problem yourself. Because now the bases are the same, and they're gone. See if we can finish that one. Do the grind it out. Takes a little algebra. If algebra is your thing, then this year and next year should go fine, honestly. It comes down to algebra, base algebra skills. You can figure out calculus. It's not that complicated. It's can you grind out the ugly algebra that's behind it. All right, so x over 5 equals, what's that? It's not 2x plus 3. What is it? 2x plus 6. Because this has to get multiplied out. That's algebra. Okay, and then times by 5 on both sides. And I'd have x equals 5 times the 2 makes 10x plus 5 times the 6 makes 30. That's what I just did there. I times everything by 5. Times, times, times. And then, if I'm going to get this alone from here, again, you just need the basic algebra skills. You want to get rid of the smaller of these two. That does bother some people because they have nothing here. But 0 is an okay thing. Plus 30, sorry. And then I subtract 30 from both sides. And then I have to get rid of the 9. Did you get negative 39ths? I think I subtracted an x from both sides. See? 10x minus the x made 9x.
Did you do it minus 10x too?
As long as you end up getting negative 30 over 9, you're fine. There is another way. I'll show you. But it'll still be negative 39ths. And in this case, that worked out pretty good. Yep, that works fine. Okay, moving on. Here's another one. This one's ugly. I didn't let it cancel nice. I did that on purpose because I want you to be ready when sometimes your answers won't work out nice and you won't have a calculator. And you aren't expected to know what 96.8 divided by 5 is. But you're expected to be able to leave it in the problem and continue from there. So your answer is just going to be ugly. It's going to have a lot of weird stuff in it. First thought is don't rewrite this yet. If you rewrite it as log base 5e, that's not right. Can't do that. You can't rewrite until that 5 gets out of there. How do I get rid of it? Divide by 5. Now I can rewrite this puppy as log base e, which is also known as ln, of, and then you go to the other side, 96.8 over 5 equals x over 3. And then is the x really close to being alone? Yes, it is. What do? Multiply by 3. When I times by 3, some people don't know what to do. I times by 3 here, and I times by 3. What do I multiply at the middle of it? Nope, just the very beginning. So now this cancels. And x is now that. Now, could you put that 3 up on this whole thing? Yes, but if you did this, I'd cry a little and mark it wrong. Because that's only putting it to on the 96.8. The whole thing needs to be put to the third. Yes, leave it to the front. It's best way to do it. Just leave it right there. All right, moving on. Try this one. It ends up being a quadratic. Don't expect you to solve the quadratic. Just get it down to a quadratic. First you can mush this side together, just like we were on the other problem. Then it'll be easier to figure out what to do. Some of you will forget an important little step and we'll get stuck. So one of the first things we learned about logs was that you can compress them together, make it into a single log. And when it's an add, it compresses down to a multiply. X times x plus 5. This is bothering me because I really want to get those logs to just cancel because there's one on each side. Why can't I cancel them right now? Because of that 5. So how do I fix that 5? Because, see, I can't cancel a plain log and a 5 log. I can't, that's not okay. They got to be the same exact thing. So how do I get rid of the 5? Yes, this 5 can go here as a power. Now I can cancel. Cancel, cancel. And now it's x times x plus 5 has got to equal 3 to the 5th. I have no idea what 3 to the 5th is. That would be an easier number on the test because we'd have actually no calculators, so therefore it probably is going to factor too, so I should have probably made that work out nice. But from there, let's just say you'd have to multiply it out. X squared plus 5x is equal to, I don't know, 12753 or whatever. And then you'd subtract from both sides, then you'd have a quadratic. But again, I know this isn't 12753, but I'm just saying. Then I could factor this, and then I get my answer. Okay, but we're not doing this one. We have another quadratic set up nice for you in a minute. So try this one. It's not quadratic at all. On the test, you would have been able to factor it and solve it. The answer might be a fraction or something, but it wouldn't have been that nasty. All right, on this kind, remember how you can't rewrite it yet. You have to get it down to just an exponential, and this is messing it up, and this is messing it up. We got to get rid of those two things. So, start by getting rid of the 4. Then divide by 7. Now it's 3 to the negative x over 2 equals 5/7. Now at least I can rewrite it. Mr. C in the back row, see if you can handle this one. Rewrite. it's currently in exponential, so now, do you see how x is getting close to alone? So we only got a couple little things left. So, give me one. Times by 2. Oh, times by negative 2 right off the bat. That's a great idea. Because that'll fix the negative and the 2. So it times by negative 2 here, and times by negative 2 here. X equals all that. See how they can be kind of messy? If I didn't have a time sign in there, it would be assumed that I meant times, so that would be fine. All right, moving on. This one looks really, really simple, but it's got a deadly mistake that a lot of you are going to make when you solve it. Try it. All right, did you start with 2 to the negative 1? It's a rewrite. So what's so hard about this, you might say? Well, first little thing is that some people won't know what that negative 1 means. That it means take the 2 and flip it. 1 over 2. Okay, so say you figured that out. So annoying. Sorry, I got this feedback noise because my iPhone is out there gathering data. Okay, so now, so I just go square root on both sides, square root of that, and then I'm done, right? Square root of 1/2. No, who was smarter than that? Ooh, why? Do you know what to do? You do have to square root it, but I'm saying, do you know that that's not the final answer? Yes. Now here's why. Because when you take the square root of the x squared, technically its absolute value of x is what you get. You got to learn that this square root of x squared is not just x. It's absolute value of x. So then you know that there's 2 answers for absolute values. Both the positive and the negative number would work, and therefore positive and negative square root of 1/2. Whenever you take the square root of both sides, notice right here and right here, when I did square root of both sides, you got to include absolute values, which will always give you 2 answers. Okay, so watch out for that. Now, what if the negative 1 won't work? X equals negative and positive. Can that number be negative? Right there. Ooh. Now, if this number right here is called the argument, can it be negative if I'm going to square it? All right. Yeah, it is okay, because once I square it, it'll be positive again. Okay, but that's something that's important to check. Watch out for extraneous answers. I think every question on the test says give exact answers. That means your answer should be ugly but not rounded. Therefore, you don't use any decimals. You don't use a calculator. And watch out for extraneous solutions. Okay, so watch out for those. All right, almost done here, just a couple more left. This one is a true quadratic, and I made it work. So if you do this right, it'll factor nice, and you'll get answers. Try it. See if you can get it without me. Got to remember, you got to do that substitution deal. Yoink the log x out and put something else in to hold its place. All right, did you say 1 over, I'm going to pick q. You can substitute anything you want in there. You could call it x, you could call it p, you could call it q. 5q. Next, you multiply everything through by q. Okay, so then I times by q here, times by q here, and times by q here. And then I'd have this one and this one will cancel, so it's 1 plus 5q times q is 5q squared. Again, if you used x, that's fine. Equals negative 6q. Then you rewrite it to be 5q squared. Bring the negative 6q over to this side and say positive 6q. And then plus 1 equals 0. And then it factored. 5q and q. And then I go plus 1. Yeah, plus 1. Plus 1. There we go. And so many kids are going to be so proud of themselves. They get to this point and they're like, yeah, I nailed it. I got the answer. Q is negative 1. And q is negative 1/5. And then they'll be wrong. What's wrong with that? Because now you got to substitute the log back in. The only reason we swapped that out is so we could make it simpler to solve. Now we've got it down to this. What was q really? Log x. So now I got to replace this with log x equals negative 1/5 and solve that. And log x equals negative 1 and solve that. So then this is base 10. So 10 to the negative 1/5 equals x. Well, that wasn't that hard. It was one step. And then this is base 10. 10 to the negative 1 equals x. And that's a perfectly good answer, just the way they are, because you aren't going to know what the 5th root of 10 is. So since calculators aren't allowed, it's good enough. Yes, sir. Yep. Part you wanted to ask about, or?
Why did you have to multiply the 5 rather than 2?
If you multiply by something on this side of the equation, it has to, I think you're thinking, I multiplied it once on this side of the equation. Nope. You got to multiply it here and here and here. I'll give you a proof. Would you agree that 5 plus 2 equals 7? If I decide to multiply both sides by 10, do you get, I can't just multiply the 5 by 10? And the 7 by 10? Otherwise, it would be 50 plus 2 equals 70. See what I mean? But if I multiply them all by 10, then I'll have 50 plus 20 is 70. It'll work. Okay, that's why. Yep.
Fifth root of 10, wouldn't that just be 1 over 1?
Here's the way you should think of it. This 1/5 power that's in there, that is the 5th root. That means like 10 to the 5th root. That means what times what times what times what times what makes 10. And it's not 2. 2 times 2 times 2 times 2 times 2 is not 10. Remember, this is a multiply. You're thinking add. Okay, so the 5th root of 10 is not 2. If you want to check it on a calculator, go ahead. You do 10 to the 1/5 power, and it's not a nice number. Okay? All right. So, last general topic. Don't forget extraneous. Is it okay if x is negative in this position? Yeah, it's okay to be negative there. If I swap it out and I move the x like over here, then I get an answer that's negative and I'd have a problem, right? That would not be okay. That would be extraneous. All right. And then remember answers like this, where it's just got the x alone by multiplying by 3/2 on both sides. That's okay. X is alone. If you have point is to solve for x, the answer that I got there is good enough. It's solved for x. Even though it's got a lot of junk in it that could be done if you had a calculator. You won't. All right, so there's your review for the test. Your assignment I'm going to give you is just 3 problems. 4. 35, 36, 37, and 38. 4 problems out of the book. They're kind of more challenging ones. And the answers are in the back of the book for those. There's quadratics in there, and those are the hardest kind. So if you want some practice, this is the ones that are going to be the R3 level stuff that might really trip you up. So try a few of them and check them with the answers that are in the back or in the book. Remember, on Schoology, the answers are stored under Files and Links. This is Chapter 3. This is Section 3.5. So, Section 3.5. Any other last questions? All right, remember, you're taking the test either tomorrow or the next day, depending on whether you have that Keith Hawkins thing or not. If you want to put it off to Thursday, it's okay with me.